Welcome to our Base 5 lesson. All right, this is our lesson on the Base 5 number system. This lesson is part of our Honors Number Bases unit. Imagine that you visited the planet Quint, where the inhabitants only had one arm with 5 fingers. These inhabitants happen to use the same numerals, shapes of numbers, as we do, but writing specific numbers on this particular planet is a little bit different than what we do on Earth. These inhabitants write in a quinary, or base 5, numeral system. Take a look at this chart comparing the numerals for the base 10 system, that's what we're used to, compared to a base 5 system. So our units are in blue and base 5 is in white. Take a moment and notice the patterns. What do you observe? What do you see? Go ahead and pause this video to take a moment to think. Hopefully you had a chance to notice some patterns. A couple of the patterns that I noticed is that you don't see the numeral 5 anywhere in the base 5 number system. 0, 1, 2, 3, 4, and then it moves to 1, 0, 1, 1, 1, 2, so on and so forth. So you never see the number 5. Another thing is that in base 10, most of the numbers that we see here on this chart are 2 digits. When we compare that to base 5, most of the numbers that we see are 3 digits. So those are a couple of patterns, and I'm sure you noticed other ones. There are no tens, hundreds, or thousands places values in base 5. Instead, we have the ones place, 25s place, 125, and 625 places, and so on. So here are some thinking questions. In base 10, how many times bigger is 10 than 1? 100 than 10. In base 5, how many times bigger is 5 than 1? 25 than 5. The number 34 is different in base 5 than it is in base 10. There are a few different ways we can indicate this, but for our class, we'll use a subscript. That's the little writing on the bottom right of the number. So we can tell the difference between those two numbers because one has the subscript base 5 and one has the subscript base 10. And as we'll see in a moment, those numbers mean two different things in terms of the number of objects it represents in the different base systems. Note, though, that since base 10 is our standard number system, if there's no subscript, assume we're talking about base 10. All right, so we're going to do some examples where we're going to change base 5 numbers into base 10 numbers, what we're used to. Step 1 says that the number 23 in base 5 is a 2-digit number. So we're going to make a table with some columns and rows. That's already been done for us. So we've checked that off. Then we're going to write each digit of 23 on the top row of the table. Okay, so I'm going to go ahead and start that here. 23. And I'm going to go ahead and copy this onto all of the tables for this problem. The next thing that we're going to do is write the place value for base 5. So starting left to right, right to left, we have the ones place, we have the 5s place, the 25s place, and the 125s place. And I'm going to go ahead and copy that down to all of my remaining tables. Okay, so that was step 3. Step 4, we are going to multiply each column straight down and write the product below the table. So 3 times 1 is 3. And 2 times 5 is 10. Okay? So that was our step 4. Our last step is to add those products together. So 10 plus 3 gives me 13. So that is my final answer. The number 2, 3 in base 5 is the number 13 in our base 10 system. The rest of the examples on this side of the page, the together problem, the partner problems, and the individual problems, we will be working together to complete in class during our lesson. So skip those now. Turn your paper over to the back. Now we're going to move in the opposite direction. So we're going to start with numbers that are in base 10, the numbers we're used to, and we'll convert them to base 5 numbers. So the first step is to write all of the place values of base 5 that are less than our current number, in this case 73. Okay, so 125 is bigger than 73, so I don't need to write that down. I am going to start with 25, 5, and 1. And just like we did before, I'm just going to copy that down to each of our steps. All right, so that was step 1. We wrote them on the bottom row. The next thing we're going to do is take our number and we'll divide it by the first place value starting on the left. So we are going to take our starting number 73. We will divide that by 25. And we are going to get 2 with a remainder of 23. So, the first number, our quotient, is 2. We are going to write that above the 25 because there are 2 25s in my total number. The remainder is what I use for my next step. So, we're going to start with 23. I am going to divide it by the next place value. In this case, that's 5. 23 divided by 5. That is going to give me 4 with a remainder of 3. So I am going to take that 4 and I'm going to write that in the place value above the 5. We have a 4 in the place value of 5. And since we're down to our last place value, the 1s, we know that our remainder is going to go in the last slot. So we have a remainder of 3 1s. So this number here in the top row, that is our final answer. 73 written in base 5 is 2, 4, 3. So I went ahead and I wrote that in my answer spot, 2, 4, 3. Once again, the together, partner, and individual exercises on this side of the page we will do in class for our in-class activity. Rewatch this video if you need to so that you are prepared to jump into our activities in class.